So my name's Dan Keller. This is my 23rd year with Lucas Systems. I've been involved in designing and delivering warehouse software solutions for over 40 years. In this session, you're going to learn about a way to achieve double-digit productivity gains in your distribution centers using smart software without having to invest in complex and expensive automation or robotics. It works in large, medium, and small operations and easily integrates with your existing WMS or ERP software. And best yet, for most of our customers, it almost always pays for itself in under 12 months. So as a comment, this session is focused on optimization inside the four walls. So most of you have interacting with a lot of people here about supply chain, broad supply chain. That's great. It's important. But our focus today is to talk about something that can happen inside your distribution center. Okay, a little bit about Lucas Systems. We were founded in 1998 as an innovative voice-directed solution provider. Some of you might know us for that. And we've been the first to deliver voice solutions on open platform, multimodal devices, as well as on Android, smartphone type devices, and smart watches. Over the past 5 years, we've had a very, very concentrated focus on software solutions under the surface. I call it you see the tip of the iceberg is the voice. Well, lots of stuff happening underneath the surface. So software solutions for on-the-floor process optimization. And it's really a big differentiator. So you're going to learn more about that today. The focus for the past 25 years has been to provide voice-directed solutions which incorporate complementary technologies, including barcode scanning, visual cues. And these have proven to be one of the most effective methods to train and retain hourly associates, which has been a big problem, a little bit less this year, but something that's really been plaguing us, especially inside the DC, for quite a while. With voice in place as the easy way to communicate with your on-the-floor workforce, we can now focus on today's subjects: optimization of the on-the-floor process, orchestration of your manual workforce in conjunction with your chosen automation technologies. Using AI and smart software to optimize the process, your associates will still do their tasks in the same manner, but the software has smartened up the tasks to save steps. With a focus on order picking, which is where most of your labor is, we're going to discuss 3 components of the solution: dynamic order prioritization, intelligent assignment batching, and pick path optimization. First of all, every order should be assigned a priority. This process can be semi-automated by establishing rules centered around desired ship dates and carriers. Plus, priorities can be changed manually or by the system. For instance, if you're nearing your carrier pickup time, the software is smart enough to automatically elevate orders which may have been received late, but which need to be shipped today. Assigning each order dynamic prioritization will assure that you can achieve the right balance between pick density, yielding the highest productivity, and maximizing your service levels. Now, I'm sure that most of you are already doing some sort of multi-order batching in your picking process whenever possible. In a direct-to-consumer process, you absolutely have to have a way to pick many orders at the same time, or else you're just wasting huge amounts of travel time. You might be using a batch cart like the one on the left side, or if you're doing pallets cases, you might be using a multi-position jack. Some of our customers use doubles, even triple jacks. So in the diagram above, we show the next 6 orders in the system, each order with different colored dots, representing the pick locations where product is going to be picked from. Using the above example, we first see the pick path generated by your system to pick order number 1. the highest priority order in the system, traveling a total of 432 linear feet. Now, most warehouses and WMSs batch in a first in, first out manner. So the user would be assigned, if you're doing batching, to pick order number 2 with order number 1 in their batch. Picking both together results in a total travel distance of 704 feet, much shorter than if they had picked them both separately. However, there is a better way. AI-based software tools track all the pick path priority and cube size of all available orders. So if you have thousands of orders in your system, the AI-based software is looking at all of those and deciding which ones, based on those priority and density, should be put together into batches. That's also depending on the type of pick cart you might have or pick conveyance. So with that in mind, if you look at the map, which order matches really well with the current pick path? In this example, order 6 in green almost matches the pick path perfectly and will make a great addition to our batch. We see only a small amount of additional travel would be required to complete both orders, resulting in only 456 total feet to complete both orders, much shorter than if I was batching linearly or if I was doing them one at a time. Consider how much greater the benefits could be once you start picking batches of 4, 8, or even 20 orders at a time. So now that we're using smart batching to create the most efficient unit of work, the second phase of AI-based smart software is to sequence the work in the most efficient path. Here we see the usual serpentine WMS-driven pick sequence based on your slot naming convention. The user will traverse each aisle that has picks in it, and in most cases travel the whole length of the aisle. In this example, they would have traveled around 934 linear feet. Now let's look at the path that is generated using a pick path optimization engine. It uses a number of mathematical traveling salesman algorithms, crunching travel costs across a digital map of the warehouse. Now we see that we have significantly reduced travel time for each user. Instead of picking those picks across the bottom in aisle sequence, we save a ton of walking by grabbing them at the very end. The result is an estimated 18% savings in travel for this order. Now, many of us have really good pickers, sharp guys in action, ones that can find workarounds or shortcuts to reduce their travel. But what about the newer pickers or your temporary workforce that you've just brought in? The AI-based engine helps to democratize these shortcuts, in addition to making our fastest pickers even faster. Let's take you through a couple of examples of how these AI-based algorithms can be applied to your operations and what the results could be. In the first example, we looked at a large operation where cases are picked to double and triple pallets. And the combination of intelligent pallet matching, which is the batching aspect, and pick path optimization results in a travel savings of 29.5%. That is huge, especially considering that most large organizations of this type have already done everything they can. They have large IE staffs. They're using labor standards. They've got slotting software. They're doing everything they can. Picture a grocery distribution center where the margins are so razor thin that, I once did a project they called the Jefferson Project because they were trying to cut a nickel out of the cost of handling a case. I mean, that's how focused they are on these because the margins are so thin. So when you can walk in and tell somebody, after all this, I can save you 29.5% of travel time, that's like, they almost don't believe it. In the second example, a global manufacturer of professional hand and power tools used dynamic work optimization, which is the AI-based engine, to maximize batch picking productivity. The solution also replaced RF and pick-to-light technology with multimodal picking featuring voice direction. The results included not only dramatic error reduction, but also a 50% reduction of labor in their pick-to-card area where 35% of their picking takes place. That's where we're using this smart batching and pick path optimization. So this is tried and true, folks. This has been proven. And the neat part is it's software. So you don't need to invest in lots of extra technology. This can layer on top of your WMS or your ERP. And the algorithms are there. So next step, last step. So now you've applied all this smart software. You've got the most efficient manual workforce ever. Next step is, what's the next step? Well, start to replace some of those manual workforces with the people, with the machines to do that. So robotics, as you know, is coming into the warehouse. The best place to use that is to take over the mundane tasks which people are doing, like moving pick carts or running pallets. Let the machines do those tasks. Where you have the opportunity to further reduce travel time for units of work to go from one place to another, and you can look at the new breed of AMRs to accomplish this. There are a number of companies now offering various flavors of automation, mobile robots, AMRs, almost all positioned to be collaborative with your human workforce. You'll still need orchestration software to coordinate the collaboration of the AMRs with your human workforce. Okay? Just pushing the robots around isn't going to do it. You have to get the people working with the robots. And so this platform that we've been talking about, the AI-based software suite, is perfect to be able to take you the full distance to give an optimized, automated process with robots and people.